Alright, hey class. I think I got everything set up the way I want it. I think you can hear me. I think you can see me writing. See. And so I'm going to run through all these homework assignments like I do. I said I'll take you guys through the Desmos activity, so I'll do that too, but I think that'll be a separate activity. So let's go through the homeworks first. I feel like we've been over this particular assignment a couple times already, so I'm going to do this kind of quickly. But basically what we're doing here is we're trying to classify all these quadrilaterals by their properties. So they're asking which quadrilateral has both of its pairs of opposite sides parallel. And that's going to be parallelogram, so you'd fill that in. And then notice there's this arrow leading you down. So there's a special kind of parallelogram there. Then there's another arrow leading us over to here. There's going to be another kind of parallelogram. And then there's even another kind of parallelogram that kind of incorporates both of the previous parallelograms. And we'll see who that is. So here it says all the angles are right angles. So looking up here, well, a square has all of its angles right angles, but it's supposed to have all of its sides congruent too. And this doesn't say that. It only says the angles are right angles. So that box is trying to be rectangle. Look over here. This one says all the sides are congruent. And again, that's true of a square. But it doesn't say all the angles are congruent. It only says the sides. And the shape that has all of its sides congruent is the rhombus. And so then finally here it says all the angles are right angles and all the sides are congruent. And so that guy must be the square. And so if truth be told, this is our whole quiz. Just these 4 special quadrilaterals. There's not going to be any questions about this guy, where we have exactly one pair of parallel sides. That's a trapezoid. But there aren't going to be questions about trapezoids. And there's not going to be questions about this guy either, that has 2 pairs of congruent adjacent sides. That's this thing here, the kite. So will we give you a quiz later that incorporates trapezoids and kites? Maybe, but I don't think so. I really think we're just going to stick to a quiz that covers just these 4 red parallelograms. All right. So that's it for 1. Scrolling down. It says in a parallelogram, the opposite sides are, well, that's parallel, of course. But it's also true that in a parallelogram, the opposite sides are congruent. That's another theorem. In a parallelogram, the opposite angles are congruent. That's another theorem. And then it says the opposite sides of a rectangle are parallel? Maybe parallel. And congruent. Maybe it's both, because a rectangle is a parallelogram. And so that means that a rectangle is going to have all the properties that a parallelogram has. It's going to have sides that are parallel, and it's going to have opposite sides that are congruent. It says here that the opposite angles of a rhombus are congruent, because a rhombus is a parallelogram too. So we're trying to establish this idea early on that rectangles and rhombuses are special kinds of parallelograms, which means anything that's true for a parallelogram will be true for them too. Alright, so now we get into some actual algebraic problems. The algebra here is pretty light, I hope. But for this, it's telling you to solve for x. So you should be noticing x here is this side. It's 9x plus 2. And that would have to be equal to the 38, because we just said that the opposite sides of parallelograms are congruent. So off to the side over here. Nah. Let's just make room. Right here. I'll show my work right there. So we're going to say that the 9x plus 2 is equal to 38. Then we can just use algebra to solve. So we know the first step we should probably take is to subtract 2 from both sides, because that's going to cancel this 2, leave us with a 9x on the left, and on the right a 36. So you'll now divide by 9. That'll get these 9's to cancel, and you'll get an x that equals 4. Okay, to solve for y, we're going to do something really similar. We can see a y expression here. It's opposite from this 32. So we're going to write an equation that's basically the same as we had before. So we're going to notice that this time around, the 3y plus 5 equals 32. So for the x, we knew that the x expression was equal to 38. For y, we can see that our y expression is just going to equal 32, and we can go to town. So subtract 5, get those 5's to cancel, and you've got a 3y that equals 27. You can now divide by 3, get those 3's to cancel, and you get a y that equals 9. So x is 4, y is 9. And then here again where it says in a parallelogram, they just want you to state the property that we're using. And the property that we're using is the property that says that opposite sides are congruent. So we'll say in a parallelogram, the opposite sides are congruent. So that's it for number 3. If you need to copy that down, just pause the video because I'm going to scroll everything down now. But dragging this down, we're going to do number 4 now. And for number 4, we're still just solving for x and y. And in number 3, we were setting opposite sides equal to each other, but you can also set the opposite angles equal to each other, because they're congruent too. So you know that to solve for x, you'll take the 4x plus 4, just set it equal to 72. And we'll solve by subtracting 4 from both sides. We'll get 68, then we'll divide by 4, and we'll get what? 4 goes in once, 2 left over, 7, so 17. Now, to solve for y, same thing. Grab your opposite angles and set them equal to each other. So you'll have a 6y minus 18 that equals 108. You'll just subtract from both sides. So if you subtract 18, then this is going to be 90. So now you're dividing by 6, which will be 15. And again, when they ask for the property, well, the property we're using is the one that says opposite angles are congruent. So we'll substitute that in. And that's it for that. Now we can do the last one on this page, which is number 5 here. So number 5 has us solving for a bunch of stuff, but I think we can see that we've got an x term here, and then the opposite side is another x term. So to solve for x, we're going to set those two expressions equal to each other and solve. We can see for z, we've got another side that's in terms of z, and then opposite from that, we've got a 92. So to solve for z, we'll just set these blue things equal to each other. Then we've also got a y expression as one of our angles, and then the opposite angle is another y. So you should notice that to solve for y, we're just going to set the green things equal. But everything here is equal. Opposite sides are equal, opposite angles are equal. So every equation we're going to write is going to be one where the given expression, 7x plus 12, is just equal to the other expression, like 9x minus 4. So to solve this, I always like to get rid of the smaller number of x's first. So the 7x, I'm going to cancel it by subtracting 7x on both sides. That'll leave me with just the 12 over here on the left, and I'll have a 2x minus 4. I'm going to add 4 now to cancel out the 4, and I'll do it over here. So I now have a 16 that equals 2x. So to get rid of the 2, I'll divide by 2 and I'll get 8. So x is 8. Now to solve for y. Well, y is the green angles that I highlighted, and they're congruent to each other too. So just take your 2y plus 50, set it equal to 3y plus 18. And I still say solve by getting rid of the smaller number of variables first. So I'm subtracting 2y from both sides. Those cancel. I now have just the 50 on the left. And on the right, I only have 1y plus 18. So to solve, I just have to subtract 18. That cancels those. We now have y. And 50 minus 18 is 32. Now we can solve for z, and those are the blue sides. So you'll just take the 5z plus 22. Set it equal to 92. So if you subtract 22 from both sides, you've got a 5z that equals 70. And then dividing that by 5, you get 14. So that's it for solving for the three variables. Now, there's often these follow-up questions where now you have to actually plug your variable values back in and solve for an actual part. So they're asking for AB, that's this guy. AB is given by this pink expression. So up here I'll show my work and say that I know that AB is equal to 7x plus 12. So I'll just take the value of x and I'll plug it in. X is 8. So plugging in an 8 gives me a 56 plus a 12. That is a 78. So the length of AB is 78 inches, centimeters, whatever it is. Now they want the measure of angle D. And that's pretty simple because the measure of angle D is given by one of these expressions too, the 3y plus 18. So you just substitute in for y. We found that y is 32, so in goes a 32 plus an 18. This is 96 plus an extra 1, 18. Just so an extra 18. So adding that up, you get 114. 114. And those are degrees because we're solving for an angle. So it's 114. Whoops. 114 degrees. There you go. That's number 5. And that's many of the rules of parallelograms that you need to know. We know that the opposite angles are congruent. We know that the opposite sides are congruent. So what else do we have? After that, it looks like we're going to add some new properties to the mix. So the old properties, we already said, were that the opposite sides are parallel. We said that the opposite sides are congruent. We said the opposite angles are congruent. And then one of our new properties was that the consecutive angles are supplementary. And if you forget what consecutive means, it means the same thing that adjacent means. And in a rectangle, parallelogram, rhombus, whatever, the consecutive angles of the adjacent angles are the ones that are right next to each other. So this one and this one would be adjacent. Or angle 2, the one with 2 arcs, is adjacent to this one. 3, the top 2 are adjacent. The only thing that's not adjacent are the ones that are opposite from each other. So this angle and this angle, those are opposite angles. But opposite angles are congruent, but adjacent angles are supplementary, which apparently I didn't finish writing the word. Supplementary. All right. And then the other big property for parallelograms was that the diagonals bisect each other. Which may or may not come in handy. So for number 2, it says solve for V. And that's V. But up here is 2W. Now if opposite sides are congruent, those things would be congruent. But you can't write an equation with 2 different variables. So luckily we notice that there's another w over here, and it's opposite from this side, that's 8. So w is just kind of automatically 8. And now that I know w is 8, I can substitute it in here to figure out that this side is 2 times 8, which is 16. Which means that side v is 16, because opposite sides have to be the same. So we just have to find w before we can find v. But I think the rest is straightforward now. We want to solve for x. And what we definitely don't know is that x and 18 are definitely not the same. That's not true. But x is the same as the 21. And the reason for that is because of the alternate interior angles theorem. I might have to twist this to help you see it. But I think if we let these sides be horizontal, it might be easier to remember that if those sides are parallel and we let this side here act like a transversal, we get that letter z that we were on the lookout for in previous problems. And I see 21 stuck inside the corner of this little z, and down here I see x. And that's a telltale sign that you have alternate interior angles. So x is 21. Okay? Let me just undo all that. Anyway, hopefully you could see that better by just kind of twisting your paper. So x is 21. And there's no work to show on that. If you just say 21, you're going to get full credit. So now to find y is even easier because we said opposite angles are congruent. And here's 141, here's y. They're opposite, so y is automatically 141, and I don't need any work shown for that either. And then you've got z, which is alternate interior angles with the 18. Just like x and 21 were alternate interiors, 18 and z are alternate interiors now too. So z's got to be 18. Technically none of those should have degree symbols. They're just variables. But that's it for number 2. So now we've got 3 and 4 that we can look at. We can start with 3. It looks to me like 3 is pretty straightforward. We're just going to use that same property from before, the one that says opposite sides are congruent. So we'll go 2x minus 5, set it equal to the 23. We can add 5, because adding 5 to a negative 5 would cancel it out, and this will go up to 30. And then dividing by 2 gives us 15. So x is 15, easy. Now we take this y expression, which is opposite from 27. You just set them equal. So if 2y minus 7 was equal to 27, then the first thing I'm doing is adding 7 to both sides. That'll cancel that. And that'll bop this up to 34. I'll then divide by 2 to find that y is 17. And that's it for that whole question. That's kind of cake. And then number 4 is where it gets a little bit harder. If you're always looking for opposite angles, it's not going to work in this case because you can't have an x and a y together. But we can say that these adjacent angles have some special relationship. Remember we just wrote it down? Maybe not. I guess it's down here lower. I don't know where we wrote it, but somewhere we wrote, right here we wrote it. We wrote that the consecutive angles, or the adjacent angles, are supplementary. And that's what we've got here. The 7x plus 8 and the 5x plus 4 are supplementary. So you'll take the 7x plus 8, and you'll take the 5x plus 4. And instead of saying they equal each other, you'll have to say that they add up together to come out to a total of 180. Now that's an equation you can solve. You combine your like terms first. So 7x plus 5x gives 12x. And then 8 plus 4 gives 12. So to solve now, you'll want to subtract away the 12, leaving a 12x that equals 168. Then you can divide by the 12. And get 14. Alright, and so now to solve for y, well now you've got y, and it's opposite from 7x plus 8. So if you could figure out angle B, then angle D, meaning y, would be the same thing. So of course we can. We just take the 7x plus 8 and we substitute the value of x that we just found in for it. So instead of 7x plus 8 being equal to y, we'll say 7 times 14 plus 8 is equal to y. So I'm just substituting. Take the 14, plug it in for x. Multiplying these together, 98. Plus an extra 8. So y is 106. So what do we do here? We used the property that says adjacent angles are supplementary. So there's my abbreviation. Adjacent angles are supplementary. But we also use the rule about how opposite angles are congruent. Kind of use both. Alright, so that's 1, 2, 3, 4. Here's 5 and 6. 5 should be straightforward, even a little redundant because we've already done it. But I see an angle and an angle. I see that they're across from each other. That tells me they're congruent. So we know we're using the rule again where in a parallelogram opposite angles are congruent. So you'll take your 5x plus 3. You'll take your 6x minus 19, 17. Geez, oh my god, 17. 6x minus 17. Just set them equal. So subtracting 5x leaves 3 and brings us down to 1x minus 17. Just add 17 and you get 20. So this x value is 20. Now they want y, but you can't find y by just finding the guy that's opposite from it. So a little bit of a twist here is you'll use your x to figure out one of these angles, probably this one. 5 times 20 is 100, plus 3 is 103. And then y has to be supplementary with the 103. So if you do 180 minus 103, you're left with 77. So you know that y is 77, you know that x is 20. That's number 5. For 6, we're going to use that brand new rule. It's not really brand new, we've been talking about it a bunch, but we know that the diagonals bisect each other. So you know that that 70 right there equals the 4x plus 2. You also know that that 50 right there equals y minus 3. So taking this in order and showing work, we've got a 70 that equals a 4x plus 2. So I'll take away 2. I'll get 68 equals 4x. I'll divide by 4, which brings me down to, I don't know, 17. I'm getting very tired if you can't tell. But I'm working through it. Alright, how do you solve for y? Exact same way. Take these y expressions and set them equal. So y minus 3 must equal 50. And then this is simple. You just add 3 to both sides. So 53 would be y. And the rule that we're using is the one that says that in a parallelogram, the diagonals bisect each other. So that's that. That might be that whole homework. It is. So on 98, this is where we're kind of working in reverse to prove that either a parallelogram is or is not, a quadrilateral is or is not a parallelogram. So they're telling us x is 12. And one way to prove that a quadrilateral is a parallelogram is just to prove that the opposite sides are congruent. You don't have to prove that they're parallel. If you can just show that both pairs of sides are congruent, that's good enough. So if I were you, I'd take my 12 and I'd substitute it in. This becomes 3 times 12 minus 4, which is 36 minus 4, which is 32 which is equal to the 32 over here. So those two sides for sure are congruent. Now I can check the others by plugging in 12. So 2 times 12 is 24 plus 14. That's 38. And then up here you can plug in the 12 too. And 4 times 12 minus 10 is 48 minus 10, which is 38. So are we a parallelogram? You'd say yes, we are. And your explanation would be something about how both pairs of opposite sides are congruent. Alright, number 2. To solve for x, I see a pair of x expressions that are right opposite from one another. So if we're a parallelogram, those will be congruent. I see another pair of these y's. If we're a parallelogram, those will be congruent. But we don't know if we're a parallelogram or not. But we read right here, it says x is 20. So I guess we'll just use the fact that x is 20 to figure out what this angle is. So 8 times 20 is 160. Take away 7 would be 153. So that's the measure of that angle. Check on the next one, plug in 20. 7 times 20 is 140. Plus 13 is 153. So far, everything's working out. Now we check the blue. This time we're doing y. Y is 10. 20 plus 7 is 27. Which seems good to me. Plugging in 10, I get 60 minus 33, which is in fact 27. So I can safely say, is this thing a parallelogram? Yes. And again, that's not a guess based on how it looks. I've used math. I've proven that the opposite angles are congruent. That makes it a parallelogram. So you'll say something like A, B, C, D is a parallelogram. Because both pairs of opposite sides. My bad. I meant to say both pairs of opposite angles are congruent. Alright, next we're still wondering if this is a parallelogram or not, but they are so kind as to tell us that AD and BC are the same. So that means whether we're a parallelogram or not, these sides at least are the same. So I can take them, set them equal to each other, and solve for x. And I'll solve by subtracting 3. Dividing by 4. So you get 6. Now that you've got 6, you'd want to take that 6 and plug it in here. Not there. Plug it in here. Because if this gives 20, then both pairs of sides are congruent and we'll have a parallelogram. But 6 times 6 take away 15. That's 36 take away 15. That is 31. 21. 21. My bad. That is 21. I'm going to just rewrite it. 21. Okay. So guess what? We are not a parallelogram because this side at 20 is not quite the same as this side here at 21. So you'll say, is it a parallelogram? No. And you can say because not all pairs. Not all pairs of opposite angles are congruent. Nope, my bad. Not all pairs of opposite sides are congruent. Alright, 4. 4 says measure of angle A is equal to the measure of angle C. So if we know that A and C definitely are the same, then we can set them equal, solve for x, then plug x in for B and D to see if we get the same thing. Because if we do, we're a parallelogram. So 4x plus 3 has to equal 7x minus 36. Subtract 4x, you're left with just a plain old 3. And subtracting 4x from 7x leaves 3 only. Then you've got this minus 36, and I would add 36 to both sides. So this pops up to 39. This stays 3x, but this thing canceled out. So we're here now. You just divide by 3 and get 13. So how does that help us? Well, we're basically wondering if these other two angles are congruent. Because if they are, then all 4 angles will be congruent. I don't know why I said that. That wasn't quite right. I need these orange angles to be congruent. And then these don't have to be the same as the other two. I don't need all 4 to be the same, but I do need 2 pairs. So let's plug the 13 in. We're going to just find these values by plugging the 13 in. So 8 times 13 plus 21, what is that going to be? 104 plus 21, which is 125. And then here, we'll plug in 13 again. 9 times 13 is going to be 117. Plus 8 is 125. So guess what? Right now, those two opposite angles are congruent. These two opposite angles are congruent. So are we a quadrilateral that is a parallelogram? Yes. Why? Both pairs. Jeez, I'm having a hard time writing. All right, both pairs. Of opposite angles are congruent. All right, so that's 4 done. Which brings us to the last homework 100. It says the 5 conditions to prove that a figure is a parallelogram are that both pairs of opposite sides have to be parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. And the diagonals bisect each other, and consecutive angles are supplementary. Okay. So with all that in mind, is this figure a parallelogram? Kind of tricky, but we've got a rule that says the diagonals bisect each other when we're a parallelogram, and that's what I see here. I see 2 diagonals that are bisecting each other, so that's a yes. That's it. Diagonals bisect each other, so yes, we're a parallelogram. Looking at this one, I've got 98, 98. I've got 73, 73. So the opposite sides are congruent, both pairs. So is this a parallelogram? Yes. Justify why? We'll just say opposite sides are congruent. All right. For 8, they're showing us that this pair of sides is parallel. Then they're showing us that these angles are 40. Well, the fact that those angles are both 40 does let us say that these sides are parallel too. That's by the converse of the alternate interior angles theorem. So we've got our 2 pairs of parallel sides. We can say yes. We can say, it's a parallelogram because we have 2 pairs. Opposite sides that are parallel. Okay, that's 8. For 9, we're not a parallelogram. Why not? These consecutive angles should add up to 180, but these ones only add up to 70. So that's not good. We can't judge this. Is it a... what are we saying? So what kind of parallelogram is it? It's nothing. I guess we'll just say consecutive angles are not congruent. No, supplementary. Next. So for this, if we're trying to decide if we're a parallelogram, then I would assume, I guess, that these are the same. So you go 6x plus 4 equals 52. Solve by subtracting 4. So this drops down to 48. Divide by 6, you get 8. Now let's check the other pair, the 41 and the 5x minus 4. So add 4, you get 45, divide by 4, you get 9. So that's bad. If you get 9, that's telling you that when you plug in 8, you can get these sides to be the same. But when you plug in 9, you would get these sides to be the same. So if you just pick one value at a time, if you picked just the 8, then plugging in 8 up here, 6 times 8 is 48, plus 4 is 52, so those sides will appear to be congruent. But if you use the same 8 like you're supposed to and plugged it in here, 5 times 8 is 40, take away 4 is 36, but this side is 41. So that's kind of showing that we don't have our two pairs, we only have one pair. So are we a parallelogram? No. Justify, only one pair of opposite sides are congruent. Alright, we'll do the same thing for this one. Actually, no, we don't have to do anything. We can see that if this is 4x and this is 2x, those will never be congruent. This one will always be bigger than this one. So are we a parallelogram? No. And you could just say something like 4x is never going to be equal to 2x. And you're done with that problem. Is that it? I think that's it. So the deal, guys, is there is more homework. There was a homework on page 103 that pertains to rectangles and other quadrilaterals. I'm not going to ask you guys to do it, but I think you should probably keep an eye on it as I do it, because there's a lot of good stuff here. There's even 3 pages worth. So yeah, I think I'm going to do it and hope that you guys listen, because you need to really iron this stuff all out. Okay. So let's run through these problems too, because you guys will need to know this kind of stuff too. Again, this is homework 103. You guys don't have this. I never gave this one to you. This is the material that we covered in the Desmos activity, really. But these are sort of extra problems. So if you guys need this practice, just pause the video and try to do number 1. And then when I go through it, you'll see if you're right or wrong, okay? But this will be good extra practice if you want it. So let's see. It says WY. WY is this entire diagonal, and it's 3m plus 8. And then we got ZX. That's this diagonal. It's 5m minus 14. Well, it says this thing's a rectangle. And in a rectangle, these diagonals are congruent. Now, that's not true in any other parallelograms, except for squares. But the only quadrilaterals whose diagonals are the same length is a rectangle and a square. So I can take these guys, just set them equal. So we'll go 3m plus 8, set it equal to 5m minus 14. We're going to subtract the 3m, so those will cancel, we'll just have the 8. The 5m, we'll take 3m away, so it goes to 2m minus 14. We're going to add 14. This goes up to 22. So that's 11. M's 11. But that's not what they asked for. They asked us to find zx. So the fact that m is 11 means we want to take that 11, plug it back in. So to find zx, you got to go 5 times 11, take away the 14. That's 55, take away 14, that's 41. Alright, if you're working along with me, I hope that's what you got too. Number 2. So it's another rectangle. And the diagonals AC and BD. AC and BD. Alright, we better draw this thing out, right? So it's a rectangle. Let's go ABCD. So AB is 9, so that's a side. And BC is 12, that's another side. Sketch and label the rectangle, and then find the length of diagonal AC. Alright, so this is good. This is practice we definitely need. You guys should remember that in a rectangle, all the angles are 90 degrees. And when you've got a 90-degree angle, and you're trying to find this diagonal, that's going to form a nice right triangle for you. You guys can see it here in red. And when you got a right triangle, you can use Pythagorean theorem to solve. So we're going to go a squared plus b squared equals c squared. We're going to plug in the 9 and the 12. And then we can just let AC, we can call that x. So we're going to plug x squared in for c. Big thing to remember is that the hypotenuse has to be c. That's it. The two legs, doesn't matter if it's a or b. You know, I could swap the 9 and the 12 and that would be fine. But c has to be the hypotenuse. So I'm getting an 81 and a 144. That equals x squared. Adding those up is going to give me 225. So now to find the answer when you've got an x squared, you have to take the square root of both sides. You're going to need a calculator for that probably, unless you can just figure out what times what makes 225. So it's 15. 15 times 15 makes 225. But if you got a calculator, you're just going to hit the buttons to get that answer. Alright, so that's it. That's the length of diagonal AC is 15. Number 3, this time we're being told that AC is 66. So this diagonal here is 66. Again, the whole thing is 66, not just this part, the whole thing. And actually, we're not a rectangle. We're a parallelogram. We're wondering if we're a rectangle. Now, we're a rectangle as long as the diagonals are the same. So what we know for sure is that the diagonals still bisect each other, because that's true for parallelograms, not just rectangles. So I can take these two x expressions and set them equal to each other. And I can solve for x. Then I can plug in for x, and if I get 33 and 33, meaning the whole thing is 66, then the diagonals are the same and will be a rectangle. So that's what we're hoping. So I'm going to subtract 3x from both sides. I'm going to add 9. I'm going to divide by 3, I get 7. Now I got to take that 7, plug it in. So 3 times 7 will be 21, plus 12 is 33. And plugging in 7, I get 42, and 42 minus 9 is 33. So that means that whole diagonal is 66. And so now, since the diagonals are congruent, we can say that are we a rectangle? Yes. And explain your reasoning, you'll say because the diagonals are congruent. So that's 3. Moving on. For 4, we're just filling in all these properties. We did this in the Desmos, but it might be nice to see it again. So are the opposite sides parallel? Yeah, that's true for everybody. I'm just going to give everybody a check mark. Are the opposite sides congruent? Yeah, that's true for everybody too. The opposite angles are congruent? That's true for parallelograms, so it's true for everybody. The diagonals bisect each other. That's true for parallelograms, so it's true for everybody. diagonals are perpendicular. That's not true for parallelograms. That's not true for rectangles, but it is true for rhombuses and squares. The diagonals bisect the two angles. Nope. Nope. Yes, yes. All angles are right angles. Nope. Yep. And nope. And yep. Sorry, that's my dog. But that's it. And then all sides congruent. That is only true for rhombuses and squares. But that's it for your properties, so you guys can, you guys can study that list to make sure you know it. Next, we got another rectangle. We've got the diagonals labeled. They're asking us to solve for x. So this is kind of just like before. We know that the diagonals still bisect each other. So we know that these two pieces should be congruent. So we'll go 4x plus 7, set it equal to 6x minus 1. Subtract the 4x, get 2x minus 1. Add 1, get 8, equals 2x. Divide and get 4. So x would be 4. So now they want the actual length of Rm. So you got to plug the 4 in. So to find Rm, we're going to go for x plus 7. Plug in 4. Whoopsie daisy. You get a 16 plus 7, which is going to be 23. So Rm is 23. That should mean that UM is 23 also, because remember, we're not just a parallelogram, we're a rectangle, and in a rectangle the diagonals are congruent. So as soon as this piece is 23, you know this guy's 23, and then this would have to be 23, and this would have to be 23 also. And so both diagonals are 46 units long, 46, 46. The halves are 23. So when they ask for UM, you'll say 23. When they ask for RT, that's just the whole thing, so that'll be 23 plus 23, which is 46. When they ask for US, that's the whole thing, it'll be 46. When they ask for the measure of RST, R to S to T is that angle. And you know that's got to be 90 degrees, because again, we're a rectangle. Rectangles have 90-degree angles. So that's easy. Then they want URS, and URS is just another 90-degree angle. So that's it for 5. Let's do 6. 6 is a rhombus. Again, don't just watch me do it. If you guys want to be good at this, then you should pause the video, try it yourself, and then wait for me to go over it. So we're solving for x. And I see x here. We saw this in the Desmos activity too. But as long as you remember that we are a rhombus, well, rhombuses have diagonals that are perpendicular. So x is automatically 90 as soon as you remember that property. Then they want y. Well, y is this angle. And I see this angle is 42. And that is another property of rhombuses, which is that the diagonals bisect these angles. So if this guy down here is 42, this guy up here is 42 as well. So we can write an equation where the 5y plus 2 is equal to 42. And then we'll subtract 2 from both sides. Get a 5y that equals 40. We'll divide by 5 and get a y that equals 8. And that's not too bad, I don't think. Then define z. Z is this side here. And I know you're thinking that opposite sides are congruent, so it should be the same as this side here, but you don't have that. But then hopefully you remember, it's a rhombus. In a rhombus, all the sides are 18. So it's 18, it's 18, it's 18. Everybody's 18. So you can take the 4z plus 6. And you'll set it equal to 18. We're going to subtract 6 to get a 4z that equals 12. We're going to divide by 4 and find out that z is 3. Now what else? They want AD. We just said in a rhombus all the sides are the same. So you know AD is going to be 18, just like the side right across from it. They want the measure of angle BAC. BAC is this angle here. So we did see something kind of like this in the Desmos again, because we've got this right triangle right here. And if I kind of just blow this up, if I pull this out, then this is 90 degrees because the diagonals are perpendicular, we said. This angle here we said was 42. And then we said the other angle of a right triangle, everybody's got to add up to 180. So you could add everything up and just subtract from 180, or you could remember that the two angles here have to add up to 90, and then 90 plus 90 would make 180. So I think the easiest thing in the world is just to go 90 minus the 42, because you know the two acute angles have to be complementary. So subtract, you get 48. So that angle must just be 48. And then angle DAB is just this whole angle. And we just found that this half is 98. And we know that this diagonal is bisecting this. So if this half's 48, then the other half's 48, giving us a total of 96. That's it for 6. Let's keep moving so I can get this out to you guys. It's getting late already. 7 says it's a square. MNPR. Yep. So if we're a square, then opposite sides are congruent. All the sides are congruent. Diagonals are perpendicular. Diagonals cut each other in half. All that good stuff. So when they say solve for x, you know that these two guys are just congruent. We're a square. All sides are congruent. So 8x minus 7 equals 5x plus 14. So subtract to get 3x. Add the 7, you get 21. Divide by 3 and x is 7. MR. So MR is just this side. And now that we know that x is 7, we can substitute the 7 in. So we know that this will be 5 times 7 plus 14, which would be 35, plus 14, which would be 49. So MR must be 49. Which means all the sides are 49 now. MN is 49, NP is 49, PR is 49. So when they ask for NP, you don't have to do any work. You know that all the sides are the same because we're a square. So it's 49 too. Then they want NTP. Well, from N to T to P is just this angle. And we know that our diagonals are perpendicular, so that's got to be a right angle, 90 degrees. TNP, from T to N to P. All right, this is something we haven't talked about before, but we know that the sides are perpendicular, right? In a square, it makes a right angle. And we know that we've got that same rule from a rhombus that says that the diagonals bisect these angles. So both of these should be half of 90. They're going to be 45 degrees each. So we know that angle is 45 degrees. Then you got NPR. And from N down to P down to R, that's just this whole angle, which of course is 90 degrees, because we're a square. Squares have 90-degree angles. So that's 90. All right, just one left, and it's a basic parallelogram, which hopefully should be not too bad. So we're asked to solve for x. I see x is this angle. I see x is this angle. They're opposite from each other, which makes them congruent. So we can go 8x minus 5 equals 6x plus 13. Then I can solve by subtracting the smaller number of x's. So that leaves me with 2x minus 5. These cancel, so I just have 13. So now I'm going to add 5. I get 18. And divide by 2, you get 9. So x is 9. Now they want to know the measure of angle F. Okay, no problem. You just take the 9 you just found and you substitute it in. So you know angle F is going to be 8 times 9 minus 5. That is 72 minus 5. That is 67 degrees. Now they want the measure of angle P. Well, angle F that we just found was 67. Now they want P. Those are adjacent angles or consecutive angles, so those will be supplementary. So you know the measure of angle P is just going to be 180 minus the 67, which is 113. So that's it for that. Then to solve for y, you see we've got a side here, and the side opposite from it is 31. So you'll set those expressions equal. You know that your 2y plus 9 is equal to your 31. So take 9 away from both sides. This goes down to 22. Dividing by 2 tells you y is 11. And now they want to know the length of side FK. Well, FK is right here. You could take your 11, substitute it in, and get 2 times 11 is 22, plus 9 is 31, but you already know it's 31. Opposite sides are the same, so this thing's got to be 31. You don't have to do math to see that the opposite side is congruent. And that's it. So that's a lot of review. It's up to almost an hour, 55 minutes here. So if you guys watch the whole thing, good for you. I'm proud of you. Hopefully it means you'll do really well when you take the quiz tomorrow. All right, I'll see you guys then. Bye.